everyone. Everyone can hear me. So I can hear myself. It's actually raining now. I hope it's not. Let me see what the feedback is like. Um, welcome to the stream. If you are just joining us, let me see where we are at. Let me see. I will save your live. I cannot see anything currently. Let's see. I have it myself. Let me know. Let me know, guys, in the chat. Can we hear the rain in the background? It's very loud. But surprised that it's not just good. Mm. Alright, so while that is going on, let's just put out the other whole again today. Yeah, good. What we want to do is I already started. Okay, it's a full project on DevNet, Azure Mainnet. This is, let me just share a backstory. Oh, the music is loud, right? Let me stop the music there. I'm enjoying the music. You can hear the music. So, yeah, I just stop the music and get started. Let me share the backstory of what we are doing today. There is this post I made. Yeah, this is the backstory of what we're doing today. So I deployed the program on Anchor. That was 29th. Today is first. That was 2 days ago. And it cost approximately 2.3 source to deploy. So now I want to rewrite that same program in Pinocchio and benchmark the difference. So let's see what how much it costs to deploy that same program. So that will be very, very fast because of time. And see. Let's see. Let me make some announcement that are live. Let's live copy this. Okay, let me make some announcement on that. Uh, what is it for the mistake? The mistake. Mm, so, what's in an encore program to Pinocchio build the open session? Haha. Is there a yep the okay, so let me copy this and make another announcement somewhere else. There we go. No. Making a post about it. Yes. Now, programs to make make the post. So should I make that? No. 1 minute. Okay, I think that's all the noise I wanted to make about it. So started. Let's get started. Let me share a link to okay. On that post, I did where is the post? Where is the post? Where is the post? Where is the post? Yeah, this one. So this is the transaction that went through cost 2.386. So deployed with this address. This is the program address. Where is it? The program address. And yeah, we created for accounts. We deployed the maximum length, completing it. All the things that come with deploying an address. It's just like DevNet, but mainnet. Still net. Alright, let's get started. Sorry, give me 1 minute. I did things to do. Aha. Sorry, I was trying to attend to a message from Discord. Yep. So, what are we doing? trying to put a Pinocchio program, an anchor program. So you can just see the documents, Solana, Swift. I think it was this one. Yeah, so this one. Um, 1 minute, but and I will copy this. Make sure. Um, Let me just. I'm trying to clean things up so I can walk us through everything. Close all on the side and close all on the side. Yeah, yeah. Okay. So yeah, this this was what I deployed. It is basically I'm looking for. Let me see if I can get the link to the architecture diagram I made for it. 1 minute. Architecture diagram. My drive. So 1, 2, 3, 4. Yes, this is the one. Open with drive. It is not the cleanest architecture diagram you find on the internet. It's also a rushed work, but the architecture diagram gave me a better perspective to what we're building. This is what we built. Yeah, I never map out of the instructions. But this is what we built. This is what I built. So this is client side stuff. I think this is the idea of what we try to do this. We come to the platform, you this is the platform we built for Switch Switch.1. Switch.1 is a live streaming platform, by the way. And I'm streaming on Switch currently. Why taking forever to load up? Yeah. Switch.fun. Bro, come on, come on, come on. Taking like 7 months to load a single web page. Internet. The god of demos. What the fuck is going on? Let me check the Vassal one. Switch.vassal.app. Is someone pushing production? Okay, this is it. Then I'm not liking it. Uh, okay, it's my internet that's causing the problem. Actually, it's not the website. It's running over here, so that's why. I think the rain just stopped after I said it's raining. So this is not the one that has the updated key. So this is the Vercel one. So what we're building is a live streaming platform. Blah 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 blah. I would have loved to show you. Okay, let me try that one again. Switched off from. Let me try this one again. Aha, now we have it. So it's a live streaming platform where you go live, then you get rewarded per the stream that you have. It's not like you have to wait for 30 days or you have to get to a certain threshold for before you can start monetizing your streams, right? So you get rewarded instantly. Yeah, yeah. So that's what it is. And the way we build it is the real reason why we're building this program for it is to make sure it is gasless. Right? So users are not paying gas in their local in they're not paying gas in Seoul. They are just paying they're just using will charge in USDC because that's the more natural way to do it, right? You want to send you want to tip a fan now, so let me show that again. Why did I close it? Let me just walk you through how it works. Let's say someone is live streaming. Assuming I'm live streaming here currently. which I am not on this platform, so I cannot demo that part. I can't demo that part. So you live stream and you tip a user. I just tip the user, and I want to tip the user. Then the user gets it. You take 8% off of it. So you don't need to have Soul to make transactions on it. Just have the agency and make gasless transaction basically. That's what it is. So that's the reason why I built this. So user signs up, creates a switch wallet. I think it will make more sense if I show the instructions here, like so. This is Anchor, by the way. So admin initializes. A user can create a streamer account. Anyone can tip a user. Then the user can withdraw their fees. Sorry, withdraw the amount that have been tipped to them. So it's not there's no threshold to it. Then admin can withdraw fees, a particular fee. Then admin can withdraw all fees, right? So let's say admin wants to withdraw what's the parameter for? Okay. So just this one is just amount anchor serialize and to serialize. Yeah. All right. So let's take it a step at a time. We want to recreate this with Pinocchio, the demo gods. Yeah. Let's see. You got chat there. Anybody's in the chat. There's a fun. Yeah, it's the rain. Sorry, it's the rain. It's the rain. It's not fun. But the rain stopped now. Yeah, thanks for pointing that out. That was 10 minutes ago, right? Yeah, it's the rain. But the rain stopped now. Um, so now let's get started with porting our code, right? So these are all the instructions that we uh, we have in this program. Initialize just does and initialize here. Just sets the state, right? So we have a global state which is just tracking the admin, the platform fee, the accounts that would have that will get the fees that are transferred to. Then supported token mint, the bump, and if this platform is alive, this is redundant. Actually, it's not needed, but we keep it track of it anyway. So that's for the global state. So we have two states: the global state and the streamer account. The streamer state. So the streamer state is just tracking the user wallet. The user wallet is a wallet basically. Then also tracking the user token account. Then the bump of this streamer. So those are the two states. So every other instruction here are built on top of I working with these states. Let's see if create first one with initialize. I explained that already. Let's start with let me see, let me just put it side by side there. Let me do a new there are a couple of tools that help you write Pinocchio from scratch that help you um, put in some boilerplate code to have your Pinocchio thing set up. But let's do bare metal, right? Let's do bare metal. So I want to put it in the Pinocchio folder. So now I have a Pinocchio folder here. Pinocchio. Let me see what's in my Pinocchio folder. So let me do um cargo. There's a cargo in its name. The name of the program is the program. Switched switch program. Then is there templates multiple here? Yes. Templates. Template. Let me do a help first. There should be a help. Yeah. Edition, there's no template. State template. Uh name. Bin name. Let me go to front office. Yes, binary edition. Your name is actually a lib. not see binary. Quiet color. Yeah, let me just do one more time. Leave. Yes, now so we should have a what's it called? I call it a switched. Oh, did I just create it inside? My bad. This should it have been a cargo new instead of a cargo unit. Else, well, we have a source, a target. I think I don't know the. Let me see. Let me see what's at the source. I just missed something up. Cat liberus. Yep, I just messed it up. So let me RM RF source RF source. What am I moving again? I'm moving the cargo terminal that I just created. These are the two things: the source, target, cargo terminal. Ugh, but if I think I did it correctly. Why is it creating it in the okay? Let me see what's in the cargo terminal first. Cat cargo terminal. Yeah, I initialized it in the same direction, so that was not what I was supposed to do. RF target terminal source then target. Aha. So let me make a new directory. Make a new directory. Switch program. And I can cd into switch program. Then rerun the script I did now, which is cargo units. Name switch program. Yeah. Yes, we have it now. So if I open that in VS Code, I what am I looking at? Okay, this is correct. Yeah, so let's get started with the things we want to pour inside. Firstly, I want to use 21. Then a list of packages I'll be using for this one. Let me fetch it. Means install Pinocchio, need to add Pinocchio pub key, Pinocchio token. I think let me just fetch it from one of my previous Pinocchio ones. Pinocchio extension, no, Pinocchio counter, no, Pinocchio, yes, I think this one. So let me just put that here. So this example and cargo terminal. The only thing I needed there was okay, all the things I needed there, just a little. So I didn't byte mock, I didn't asset token account, I didn't logger testing, so I didn't Pinocchio PUBG for some reason. You see that Pinocchio token for token, Pinocchio system, that system, Solana, instead of the Solana system, you see it though. So then Pinocchio 0.9. Then for dev dependency for testing stuff, I test them 0.6, I test them 0.6. I will just copy all of this, copy all of this, then paste them right here. I was supposed to come to the front a bit. Yep, scroll. Yeah, so it's time started. Let me check if I'm not clocking my CPU system monitor. Almost start to close one thing, a lot of things in the background. Let me close if I'm I don't need this for now. I don't need this for now. Close this entirely. But that's what I need. So I've explained what we're doing. We need this. I'll go and I need I don't need. Okay, let me leave this for now. Then instead of putting it here, bring it to this place, which I name it computer terminal. Still installing all those dependencies I poured in. Yeah, so let's just give it a minute. Rust analyzer is still doing stuff. Let's give it a minute. I will, I will do justice to that after. Somebody just made a post about our capstone project. I'm looking at the tweet. Alright, yeah, we'll talk about that later. What the actual chicken is that? Okay, I think we're done with Rust Analyzer. Then, yeah, yeah, this should still come down a bit. Why is it still up? Okay, I don't need this one also. This one. Okay, this is the Anchor program. I think I should just fetch this from GitHub to reduce the stress on, like you see, fetch GitHub from main branch 2 months ago. 2 months ago, yeah. Let me fetch this from GitHub and close this instead to do this one. Let me see. Yep, we have switched one. Source instruction. Switch one. Okay. Okay, so let's just get started then. Remove the targets now. So what I need is to restructure this. I need instructions, instructions, instruction, instructions. Oof. Whichever. I need state. So if if it states, this should be instruction. Instructions. Instruction feels odd. State instruction. That's all. So now librs, we have to remove all of this. Then let's get writing. The first thing we need to do is to, for every Pinocchio program, just like an anchor program, right? There's an entry point. An anchor is called, okay. There's an entry point to every program. That is where all of the other instructions tap off of, right? So there needs to be one entry point. And in Pinocchio, it looks more like this. Let me fetch colors. Code. I should even share the link to this fundraiser I'm using. But no, no worries. Yeah. So we get a entry point, you write the process instruction, and we copy this and remove everything inside of it. So we have a function, a simple function. I F. Let me remove everything inside of it first. So we just have a simple function like this. This is where the magic happens. This is this is the router, so to say, that knows what instruction is coming to your program based on the discriminator, right? So, and we can store, we can import the things that we need on top here. This is Pinocchio accounting for, going to accounting for here. I did not need accounting for anywhere in this place. Okay. Yeah, entry point need the pub key because I need pub key. Oh, I need the accounting for. Sorry, my bad. An accounting for the accounts they are sending to this instruction accounting for. Then we need to declare what entry point this is. So this is where our entry point is. This is a macro. That's why this is our entry point. So this program is where all our is the router program. Are specifying that this is the router program to our instruction basically. Then we can now do Pinocchio declare ID. Yeah. So Pinocchio pub key declare ID, just like what we have in Anchor. Let me pull that up. In Anchor, it's still the same declare ID, right? So in Anchor, it's still the same declare ID. We would have something like this in Anchor, blah blah blah. But yeah. So how do we? Let's see if we already have. If we do, let me make sure. Let me make sure. Let me see. Yeah, program result. Let me just put OK here for now. This looks familiar, right? This feels very familiar. This just like any external program, right? Put my phone on vibration. Uh, yeah. Okay. So let me build with cargo. So to build a program, you do cargo build. You build an SBF. So it would install everything. Let me see what things like the SBF. So just compile, and if it needs to fetch, like it's fetching from one repository here, fetching from this repository, fetch, compile, and do everything that's under it. I think I'm safe. Let me see if I build, if it will give me a deploy. It did not. It just gave me this SBF Solana something. Alright, so what we want to do is target. We need to have a deploy. Right. Let's do Solana keygen new. Then output is, can you see? Okay, let me do this. Solana keygen new -o is target. Sorry, target that works. So I don't like it. Dot deploy. The name of the program is, what do we call this program again? Switch program, right? Are you at Cargo Tumble? Switch program. Program JSON, and I want it to be silent. So I don't want anyone to see what the private key is. So -s silent. Black again, new -s, blah blah blah. And if I wanted to grind some keys, I could, but let us do this right now for sake of sanity. Then yeah, yep. So now we have a deploy and we have a switched program. It should be a switch program keeper. So CP targets. I just want to rename it, right? Target deploy switch program JSON to target deploy switch target deploy, not debug, deploy switch program keeper JSON, and I'll do something. Yeah, should be a move. Renaming it move. MV. Yeah, now so it says switch program keeper. Yeah, I just renamed it. Okay, so that's cool. Thanks, Emmanuel. Yeah. Shout out to Emmanuel, though. This guy is amazing. More about Emmanuel. Then we talk about Mojo. Yeah, so I'll just close that. Oop. Okay, so what do we want to build? What do we want to start with? Let's see. Then let's start with our states, right? So this is the tricky part. You don't have all the guardrails from Anchor. You don't have Anchor deserialized, Anchor serialized. You don't have. In fact, today we use Anchor serialized and Anchor deserialized in Anchor mostly. Only if you are creating a custom struct that is Anchor should use. You don't have derive in its space. You don't have all of that. So what we do, the magic we do is we use the magic of byte mock. So let's create a mod array here. Mod arrays. And what are the states? The state here is, let me bring it here, switch program, states, states. The two states here are global state and streamer, right? So yeah, yep. So these are just some caveats I should take note of. So, but before then, global state.rs, we have a global state.rs. Yep. Then we create, okay, we have another one, streamer.rs. Streamer.rs. My mic too loud. I think my mic is too loud. Sorry about that. Then, so what are these? Well, we create a struct, basically, same struct, but we're doing something different now. Because I want to work with raw bytes, I want not like raw byte. I should not say raw byte. I probably should not say raw bytes. Right? Say scale of some people. Because I want to work with, I want to be very granular and save the number of serialization thing. What I can do is first I'll use bytemock to make this um to align backmock to align all of the zero copy thing inside of this program, right? All of these states. So I want to my state rs. I want to import bytemock. So we use just pod and zeroable. That's plain old data and zeroable. Then copy some stuff. Basically, that's what it is. Yeah, so we use bytemark, pod, and zeroable. Yes, this is the magic of everything. Serialization, I'm not serialization. Everything zero copy in this program. This is magic. One of the magic things, not the all magic, right? So first thing we um need to tell the compiler how to arrange this, how to use this struct, right? So we wanted to do a RAPR representation. So that means however C handles this in maybe in increasing, ascending or descending order. If one, let's say I have an enum, let me do an enum example of enum my state. Assuming we have an enum my state, and I say initialized init is non-init. Yeah, assuming I have this, right? But over on this, I don't think I have anything yet until I come here and do obvious. What's the guy's name? Global state. Global, not you, brother. State publish pub mod first before publish. So I need to import the module. It still will not work like that because I've not imported this state in the lib. So I need to use just import everything right now. Use create state create. Then this state is I think mod. No. mod state. Let me just do mod state. Mod state mod instruction. Is there have I written a mod is an instruction or yet? Let me do that right. Mod.rs. Yeah. So in the label rs I can do mod instruction to modify from mod state. So in this place now, if I start writing pub mod global state, another pub mod. Next one is what? Should streamer. Yeah, then pub use streamer, everything inside of that. Yeah, so we're good to go now. So now I have, so if I save this, there's an error here, right? If I over on this, you see, you just have my state in it and none in it. But if I want this to be represented in the way C will handle it, I can just do a represent C. I could say U8, that works too. If I over on it, let me just see now. Okay, still not. But now this would mean it will handle it. If init is 0, non-init is 1. It will order them in the same way, exactly, or always exactly the same way I arrange it here. So it will not, if you want to do some mod optimization, it would leave this in the same order as C would also use it. So that's basically what we're doing with this RAPRC. So to keep all the these states, all, everything is bytes, right? So to keep it in a packed form where you cannot have some misalignment. Right? So now let's move on to the important things. So derive, I want to derive pod on this struct here. I want to derive pod, plain old data. I want to derive, other one is zeroable. Then for some reason, if I need to clone, copy, if I want to print out, I need debug, and I also need partial equals. So yeah. So now I don't want to store, even though I could, I don't want to just store things directly as pub key, non-pub key. So let's get back to our basics of data size. Why am I always missing this? Yes, rearrange the struct. Darren said rearrange the struct in descending order. Yes, descending order. So that's basically what this RAPRC does, right? It keeps it, it rearranges it in a descending order. Thanks for that, Darren. So let's get back to, well, for 30 minutes in already. So POD is that. So now he's complaining because he does not understand what type those guys are first. So let's get back to our anchor basics, our account basics. We know that if you have a pub key, what's the size of the pub key? You can tell us what size of the pub key is in chat. The size of the pub key is an array of just U8 of size 32. So that's the size of the pub key, right? So U8 32 length. So that's basically what the size of the pub key is. So I want to implement the way it is stored in the way it's stored in byte. That's basically what I want to use here. So I'll be using the byte representation of those data structure. For U16, it will be U8 2. U16 will be U8 2. The pub key will be U8 32. So same thing goes for here, same thing goes for here. So it will be a U8 1. And this one is also a U8 1. Bull is also a U8 1. Yeah. So now we have our state. Basically, this is just a U8, bump is a U8. This is also a U8, initialize a bull U8. This is a U16. This U U8 in 32 places. So that's a pub key. This is also a pub key. This is also a pub key. So that's one way you want to start thinking of handling data in states. Because when you do it like this, you actually get to understand what's going on inside with your data, right? So that's because we have pod and zero. If I just did U8 here, I might have an issue with pod because it needs padding. Is it? No, it did not. So let me just leave it as an array. Yeah. So now we already know the size of the bump, we know the size of the initialize, we know the size of. So now we know exactly what we can now calculate the length of this guy, right? Let's create an implementation for that. Just like we would do, just like we would do derive in its place, I think, in anchor. So this does not exist here, so we have to just write the length for ourselves. Implementation of global state. Uh, let's do podcast length type u size. I think u size, yes. So u64 u size depending on your architecture, computer architecture. So we can just use core, then memory, then size of this size of what is the size, what is the structure, what generic are we using? Global states, then that's all. So we now have the size of this thing. So that's 32 plus 2 plus 32 plus 32 plus 1 plus so that's basically the total size. So we can now have a way to calculate that. So the size 100 basically. Alright, let's get to the next thing. In our let me check global state. So that's the global state, right? Let's see the other second state we created was streamer. So this one is just basically 32, 32, and U8. So let's do this also. In my streamer, I want to do this pub. So this one is U8, 32, same thing goes for here, U8, 2, U8, 1. Let me do it like that. So now I'll use byte mark on top of it. So I can use the reason why I'm using byte mark directly is if I want to get this thing convert it to bytes, right? And I want to do that. So if I want to, because be moving everything is like I said, everything you're working with bytes, so be moving bytes around a lot. If I want to just have a simple implementation to convert this whole struct into bytes, so I can do that. Right. So that's basically why I'm using byte. So to just handle all of the bytes without using unsafe directly. So let's import all the thing we imported. Use port and just write it. Use byte mark. The one we used there was pod. Second one was zeroable. I think. I guess. I think. I guess. Then we go derive and just copy this thing. There's no time. Let's derive all of this on that. Why is there a space here? There's a space here. So let's copy all of this. Just paste it on this. Derive. So what's the problem now? What requires RPC? Yeah. What also requires it? It requires the representation of C. So you need to arrange it in something like that. Just like how what Costa Darren said, right? Yeah. Now we're done with the states. So let's get to one major part of the implementation that I wanted to talk about. So when you get the length, you already know the length. Let's do another one for 2 bytes. Basically, just I think I've implemented this. Yeah, it just 2 bytes and it takes this self and returns self. No, it returns vec in bytes. It returns a vec of U8, which we should not even use. There's a better way to do this instead of using vec. So you can just okay, instead of using vec, I can just return an array of this size. Yes, I think that'll be better. So let's do byte mock, then bytes of this. Wait, let's see. Why is it showing me an error? Let me save this first. Bytes. Oh my god, that's fine. Bytes. Bytes of self. So it can return. You can return this as. Let me see. If I remove what this return type is here, I see. As I said, blah 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 blah. So it could return it as a mm, U8 of learning. What am I writing? It turns out U8 of learn. Since you know that is what the fuck am I writing? Why did I put in brackets? It should be yeah. So cannot find learn the scope. I think is I think U800 found. Yeah, and I need to do this found. Yeah, yeah, that's into think it should solve that. No, no, I think if I borrow it, if I borrow it, yes, if I borrow it, it should. I borrow it, it should just give me whatever that is, and it still did not borrow of a borrow to borrow already. Yeah, don't. Let's use a vec. I'll get back to this later to optimize it. Let's use a vec for now. Vec of it. So dot it. Can I have it to the asref? I think if I do asref, I can get on it. No, it is still. Let me just do it to vec. To vec. Let me see. Let me see. Looking at this. Okay, not good. So if I save this, the error is gone. I know just want I don't want to give back directly. I could have just used the bytes array, but we'll get back to that. It's not a problem. Then I need this implementation for streamer. Implementation streamer. And we have this that the length also I think basically the two things. Yes, length. Maybe the length of this also. Direct coaster. Yep, and I need this of streamer. Streamer. Yeah, so we're good to go. Now we have the length of the state and you can convert it to bytes. You see now you feel like an engineer, right? Because you're not using training rules. Yeah. Okay. What error is this one? As you tell items inside blah blah. Uh, what is it talking about? I think it's because we have unused. Yeah, I think that's why. But we're going to use it, so just relax. All our states are done. So for the instructions, let's get to the first one. First instruction is what? First instruction is okay. Internet. The first instruction is this initialize. Where is initialize? Where is it? A global state RS. How do you call global state RS? Then so we have a global state. Okay, before I get to that, in the instruction module, we need to just have a way to map out our instruction into the instruction coming to this place, libres. So we can do this. We just want to get the instruction from from this instruction data. I want to slice out the discriminator, right? So let's discriminator then data. equals instruction data that I think is first, split first, yeah. So we could do that. Let me see. And we are going to want to get the discriminator of this. So when you're sending an instruction, the discriminator comes first, then the rest is the data, right? So why isn't one byte discriminator instead of a 2 byte discriminator? So just this first byte, the discriminator we need in the libres, I think. Yep. So yeah, that's basically what I did. So instruction data, split first, and okay. Or if we're not okay with it, we panic. Pinocchio programmer. I think we have program error. Let's do program error. Pinocchio program error. Pinocchio program yes. Pinocchio program error. Then invalid instruction data. And we are good to go. I'm not reading this anywhere. That's why it's shouting at me. So what we can do is in the instruction you need to have want to just have a an enum that keeps track of all our instructions, just like I was demonstrating previously. So the mod instruction mod here. Let me see how did I do it here. So instructions mod rs. Yep. I did tell me loading page. Yeah. So what's the name of this? This is called yeah. This is what I was saying. This is an example from what I did previously. So if I remove this RAPR represent U8, I'll have to directly specify. But let me put this back, and I can remove all of this. I will not directly to explicitly tell it, even though it should know. I'll not explicitly tell it this is one, this is two, this is three, this is whatever. So this is zero, this is one, this is two, this is three. So, but we're not doing fundraising. We're doing switch right? Switched instruction. What are the instructions? How many instructions do you have? Yeah, let me check instructions. Source, libres. Have one, two, three, four, five, six. Six instructions. So initialize, create streamer, and just copy that. Initialize, create streamer, tip user, withdraw, tip user, withdraw. Next one was admin withdraw fees all. I think that was a handful. So we have pointing to the instruction side. So we just want to do a try from implementation on it. So we can try from since we're getting it as U8, we want to convert the U8 into this enum. So to do that, let me just copy this again. Okay. Yeah. Try from for switched instruction. Then we have a switched instructions switched instruction. Zero is initialize. Just copy this. I think where did the background music go? Just to have a good one. So okay, let's try to brighten up. Mute. Yeah, initialize. The second one is create streamer. I copied it again. I thought I paste it. Just create streamer. This is a repetitive task. Nobody does repetitive task. Nobody does actually. Then tip the user. Next one is after tipping the user. Next one is withdrawing the funds. Withdraw. Yeah. Next one is admin withdraw fees. The next one is 61. Sorry, 61 is admin withdraw fees all. I and I think we are good to go. You set up all the instruction handlers right here. So we can now move. We can use this guy here. We don't have any instruction yet, right? So that might be. Let me just start with instruction. First one we want to work with is initialize. Set it right here. So instruction initialize. Like the RS. Next one is create streamer. Create streamer. I knew it was this cap lock. I don't know why cap lock that we just skipping. Create streamer. Create streamer RS. Next one is what exactly? Create streamer tip user, I guess. Not here. No, tip user .rs. Just take this and paste it here. After tip user, we have withdraw. Withdraw RS, we have admin withdraw fees. Admin withdraw. This one can have two instructions. Yeah. Admin withdraw .rs. Okay. Now I think we are getting somewhere. So we have this discriminator split out from the rest of the instruction data. Then we can proceed to write the rest of the match. So we can just match, right? We can do match, what's it called? Switch instruction. Switch instruction. So when it is what's the name of this guy again? Switch instruction initialize. When we have initialize, we do handle it, right? And it's not just trying. Let me just copy it of writing scratch. React, Embarrass. Yep. Okay, we also supposed to try from because in it's supposed to try from discriminator. Yeah, we get this instruction, then we get the discriminator as the enum. So if the enum is initialized, do the initialize instruction. If it is the next one, do the next. So if it's an error, return this error, program error, invalid instruction data. Yep. Cannot find discriminant. How did I spell discriminator? Discriminator. My bad. Did I spell it wrongly? Then data is not used, I think. Uh, try wrapping. I wrapped it. I did wrap it. Split first. Okay. Okay. Oh, this one. Yeah, that was the one. So now we need to handle. I need to create an initialize instruction, right? So let's go to the meaty part of what we're here. We've seen how to create a state, and we've seen how to create a state, we've seen how to create the module, instruction module, the beautiful instruction discriminator. If you know how to do it this way, you would have been doing match discriminator. If discriminator zero, do this, or match discriminator zero, but this is meta, it's just more code, but it's meta. So let's get to the initialize. Let's see what are we doing in the initialize here. In the initialize, we have instructions, global states, initialize. So how many accounts do we have here? One, two, treasury. Let me just think. That is in source, instructions, initialize. So yeah, this is, let me write. Just copy this quick. Now we have process initialize. Just copy process initialize. Then program results. Yep, this one. So account is account info. Account info. Okay, it's not mod rs. So now I need to use. Let me just import everything. For mod initialize. For mod create streamer. For mod. For mod create streamer. For mod tip user. For mod coordinates again. Withdraw. For mod admin. Withdraw. For mod admin withdraw. Oh, sorry. That was basically all. I'll combine the two admin functions inside this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, cool. Then use them. For use, initialize every single thing inside of it. For use, create streamer. No, not create. Create streamer every single one of the instructions. Same thing goes for tip user. Tip user. Uh, Same thing goes for withdraw, for abuse, withdraw, for abuse, admin, withdraw. But yeah, 1, 2, 3, 4, 5. So now in my instruction handler, so if it is an initialize instruction, then I can call process initialize with the accounts I have here and with the data I have here. So I can just do this question mark on top of it, and that's all. Sweet and beautiful, right? It makes sense, so to say. If it does make sense. If it doesn't, it still makes sense that it doesn't make sense, right? So yeah, we're good. Yeah. Okay. So that's okay. So let's get on with initialize, right? So what do we want to do here? We need to know first thing. I like mapping out my instruction like this. So let's create, sorry, fetch the accounts. So don't fetch the accounts that are coming from the clients, from the test, from wherever the accounts are coming from. We need to fetch all the accounts, right? I know I've not imported you. I know. Let me just import the brother. Account info and program results. Account info, Pinocchio account info, then program results, some Pinocchio program result, Pinocchio program result. Yeah, that would do. And I need to return an OK here if I want to stop yelling at me. Okay. Uh, okay. So let's get all the accounts. The accounts is an array of accounts is for that, so you can destructure that. Let's equals accounts and just copy and explain on the copy. So blah 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 blah. That's this one. This is it's it's not it, but it's it. So all the accounts that you're expecting, you can structure it this way, and whatever else comes after it, you do not care about whatever other account is coming with it, right? So just ignore the rest. So I need differences for the rest. I share taking program. Do I need it right now? I think I do. Share taking program. Taking program. Right now I might. So let me just check here. So we have the signer, the global state, treasury account, token mint. So signer, global state, treasury account, token mint. So let's call this signer, global state, token account, treasury mint. I am in treasury. Then next one is token mint. System program, architect token program, token mint. System program, architect token program, then token program is the order. So let's keep that order. Yes, so these are all the accounts we need, and the rent is for because we don't want to do rent get. So because we don't want to do, we could, but that's like 100 Cs. I just want to save the 100 Cs. We don't want to do rent get blah 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 blah. So we can just extract it from the rent account that is part of the client. We do that as cool. So yeah, um, so we are fetching all of the accounts that are needed for destruction. So the first thing, let's check what are the process that we did here. We are basically just creating the account, right? We're basically just assigning the state. That we don't have a set in our, but I'll show you how we do it. Then we are creating the account. So probably calculate account rent, calculate account rent to rent, calculate account rent, create account, write mutably to account. That's basically what I want to do here. Calculate the rent, create the account, then write the data to the account. Simple and straightforward. That's basically what I want to do. So before then, we need to make some checks because we don't have Anchor to do all of this documents, executive authority, executive blah blah blah. So we need to write these checks. Right. So we need to assert that account global state is empty. Let's start with that. State is empty. What else do we need to do? We need to assert that signer is a signer. So we're doing all the security checks, right? Then we need to assert that we are a using using a 6 decimal token, just whatever reason why. What else? What else? What else? What else? What else? What else? We need to assert that is empty, assert that signer is a signer, assert why using 6 decimal token. What other security thing do we need to use? So the token accounts also. Assert the token account is of the mint, right? So that means the mint is the same thing, right? So the mint address of that token account is the same as the token mint, i.e., token mint is equal to token account mint. Okay, what else are we checking? What else are we checking? So you're the engineer here, you have to make sure there are no loopholes in your program. So token program, uh, rent silver, rent is balance and design anything to check. We could check, but that's an overkill. We could check that the rent is is actually the rent address. We could check that the token program is the actual token program address. We check that system program is actually the correct system program address, but that's the client will check that. So then I will check that. Then will check that for you itself, right? So we might not need to do that. So I think we are good to go on all these account checks. So right, first thing we need to do is asset that signer is a signer. Let's start with the first one. That is the same asset. Excuse me. Asset signer dot is signer else yell at us and tell us signer should be the signer. And that is done. Just simple stuff. It's not complicated. Yet it's not complicated actually. Yeah. What else have we done? Asserting that global state is empty. So I said that there is one thing which you might get into when you're writing program. I hope we get into that bug. I'll show you how to work around with scoping. But yeah, let's just see. We might have issue with scoping in token transfers, so we'll get over it. Asset that global state is empty. Global state that I think there's an is data is empty. Let me check what indicate whether the account data is empty. Account data to be empty if data length is zero. Yeah, you need to asset that is just for creating the account. So global state. There's a better way to do this errors, but I just put it here. Global state. Even these errors will not show. This logs will not show. These errors will not show if I don't make it into a proper error. Global state should be empty. What else? What else? What else? Asset wise and six decimal token. So we need to now. This is an account, a token account, right? So we need to fetch that token account as a token account. Now it's just a regular account info. We cannot say, let's say, token account dot mint. It's not a token account. We don't know that it's a token account, right? We need to pass it as a token account. So we can use bytmark. Let's so token account state. It's actually mint. So we're looking for the mint. Let token mint state. Why is this in caps? Rather? Token mint state is bytmark. I did for bytmark. Bytmark. You can just read data, right? Read tripod read unaligned. Yes, tripod read unaligned. Or should I do try from byte? Try from byte. Let me do tripod read unaligned. Then I'm reading it as a mint account. Mint. Pinocchio token state mint. I think. And I want to read the bytes of the token account. So I'm reading token account dot wait. Can you get it lights on it? Okay. Try borrow meet. Try borrow data, not try borrow meet. Try borrow data. So try borrow data is giving me cannot convert Pinocchio account ref U8 into with expected reference Pinocchio ref. Consider borrowing here. I should borrow here. So what's this problem? Okay, let me see. Mint, 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 having mint here. This is it should be this mint should come from token, not let me see. Mint authority supply decimal. Yeah, this should work also. Required for mint to implement any bit pattern. So let me use try read um from try from bytes. I think that work. Same thing. Uh, byte multiply from bytes means. Let me see. I think there's a way to do it. Let me just check how do I do it. Mm, one involving tokens. Okay, 1 minute. Let me get that repository. Live coding, right? This one, yeah, it's the same repository. It's actually the correct repository. So is there a token mint, vault, the vault state, mint state? Oh, sorry, my bad. I'll try to read. I'll try to use Bytemark. Try to overuse Bytemark. So there's a better way to do this, right? So since it's a token account already, it's an account info. We can just use dot account info on it. So we could just do what's it called again? Mint, then try from account. Let's try from account info or just from account info. Yep, from account info. Then the account info of the token account. Yeah, I was using Bytemark, my bad. Token means I'll use Bytemark for other data, like the state data. Yeah. I'm supposed to borrow, it's borrowed already. Yeah, so that works. So now I can have on it. Yep. Yeah. So now this is a mint. Token mint is a mint. Now I can now assert and I can assert that token mint states. I hope you guys are enjoying Pinocchio. It's cool, right? The decimals, now we have a decimals on it, right? Is equal to 6. So this is U64, right? U8, yeah, sorry. Equal to 6. Else, so you can't use a what? Only use a 6 decimal token. Decimal. Only the 6 decimal uh, token. And cool. What else? So that's cool. We're good with this assertion. Then we assert that the token account is of the mint. So token account we use. There's also a token account here from um, Pinocchio. So let's same thing. Let token account state. Everybody enjoying Pinocchio. Everybody's enjoying Pinocchio. If you guys are not seeing enjoying it, you should enjoy Pinocchio. Pinocchio is amazing. Let me see. Yes. Let me see. There's a chat. The chat. Okay, good. Uh, token account state equals token account. I have a token account from Pinocchio State. Yes, token account, then try. from. What am I always trying? Let's go for it. Don't try. Token account. Token account. Same thing, right? So we check the assets that the brother is also of the mint, right? So we assign that token account. That means not bad. All of that. Token account states. Token account states. That means mint is a pub key, right? Yes. Equal just asset equal, bro. Asset equal. Yeah, it have be possible. Yeah, possible. Okay, okay, it would be possible, but greater than will be possible yet. So asset equal token mint and but token account, not token account, token mint dot key else we provided a wrong token account for this mint. Let me just put wrong token account for mint. Yep. I don't have to include everything with strings and all. So we've asserted that this is correct also. Now let's calculate the rent. Right? Let's get into the interesting part of it. Calculate rent. So initially, if you wanted to calculate rent, you just do rent, and we do rent. No cases back, I think. Yes. Rent get that minimum balance of what's the account we're working with. Global state, global state dot data learn and yeah, we could do that, right? But this would cost us like 100 C. So let's just extract it from the account, from this account that we're passing here, from this rent silver account. So a way to do that, I think there's a trick that should not send at least screenshot. Let me see if I can find that screenshot. Pictures, screenshots. Where are you at, bro? Where are you at? Is it this one or this one? Not this one. When is it? I think it is. It was. It was not this one. It was not this one. I think it's this one. I think. Where is it? Where is it? Calculate and research states. 1 minute. I'm trying to get. Did I screenshot the wrong thing? Yeah. Yes. 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 So I found it. This is it. I did a screenshot of. Sorry, my bad. Come on here. I don't know if you can see it, but this is it. Rent, rent from account info, then the rent silver account. Right, so that's what we want to do. Yeah. So let's do rent instead of getting. We just do rent from account info. But also then we provide the rent silver account. Rent silver account right there. Let's see. Let rent state. Let's rent state because rent from account. So we have a rent now. Cool. So we can now use that one for calculating what we want to do. The 1 minute. The 1 minute. I think it should be exactly the same way. Okay, so, okay, account, that's great. Hmm. Yeah, yeah, yeah. They use them with class resources. Yeah. The it should be this way. So I can do rent state dot due amount, the due amount, minimum balance, yes, minimum balance, same thing. So you can now get it from that account that was sent over instead of getting it on chain, right? So data length is still global state, global state dot data length. It should be empty currently. So minimum balance rent, so blah 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 blah. It should be a U64. Let's see what was the problem. Expected found reference. But I is there. It's not an array. Did I do something wrong? Comment. Expected account info. Found account info. Friends from account info. Silver. Silver. Why is it an array of account info? I think. Why is this an array? Never that one is not an array. Now it's an account info. Oh, okay. So rent is var. Let me just do this. No, let me just remove this then. Yeah. Yes. Okay. 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 Means rent is var is an array of other things. I get now. Understand the syntax there. But yeah, let's just do that instead. Minimum balance is this one. Yeah, so it works now. So minimum balance is of type U64. So now we can create accounts. But before then, before creating the account, we need to know the seed of the account, right? So we need to pass the seeds in. So the seed has to be basically the same seed that was in there. Let's sign up. Let's not sign a seed yet. Let's seed equals seed seed from. Yeah, first thing we need to do one validation. We need to do one more validation. We need to assert that global state computed off chain is same as the one computed on chain. Yes, so that's the last assertion we need to make, right? We need to be sure that the account your person has global state is actually the account of a deriving of on chain. Let me do it what derive. Computed C is very heavy and CA intensive. You can compute off chain and derive on chain. Yeah, that sounds good. Mm, so global states. So let's check global states. So we can do a net token account. Let's derive PDA. Let's call it derive PDA and bump. Excuse me. Was pub key. I don't even supposed to use the Pinocchio pub key. I can use pub key from here instead of Pinocchio pub key. There is a pub key here. Yep. Can use pub key. Let's use pub key. Think find program address. Seed is an array of what should we use the seed for? This one is a what were the seeds of this guy? The seed is just global state. Just global state. So let's use global state. Is an array of arrays. We have the global global states. I think. What did I write? What did I just write? What did I just write? Global state. Yeah, global states. That's all. So program ID here is our crate ID. Yeah. So global state and crate ID. So this is the derived PDA. We need to assert that this derived PDA is the exact same PDA that is coming from this guy. So assert that assert equals assert equal derived PDA dot key. So key derived PDA is okay. It's already a pop key. Derived PDA and global state dot key. Let me borrow this one since that was borrowed also. Assert this um global state does not match. Aha. So we have this assertion. We need to make sure that it actually matches before we create it. Yeah, right. So now let's create this seed. Seed from seed is important, right? Seed. I did not input seed. Seed is from Pinocchio instruction seed. So seed from is an array. It's an array self-sized. Yeah, it should be an array now. It should be an borrowed array. An array of this guy. This guy should work. No. Yes. Should not be an array. This would fix that itself. I think. Yeah, so one of these is so this one will now be an array. So and the bump then can do bump, but that will not work immediately. Yes, because it should say seed from bump, not bump. Seed from and our bump is an array of so you can just do it's just 1 byte, right? So you can do from zero, I think cannot convert cannot index into a type of U8. Okay, so it's a U8 already. Oh, sorry. This bump was not saved to the bump, so it's still a bump. And now it's saying from U8 is not satisfied, so it should be U8 and 1. I think. So it's not satisfied, right? Should be borrow of that, I think. Yeah, that's good to go. Let me confirm if what I'm writing is actually correct. Yeah, bump, initial bump, 100, initial bump. Yeah, yeah. Initialize bump. So I could just, if I wanted to make this more complex, this was what I did. So I did, yeah. I did the bump and I converted it to little Indian bytes because that's what it should actually be. Initial bump is this bump that we got here. U8, we converted the U8 to little Indian bytes. and we got the bump and put it into this. So we are now putting bump here. Yeah, but basically the same thing. I think it should be the same thing like I did. Should be. So early byte converts it into the array of U8. So it's just uh, bonus. Alright, so that's cool. I think it's cool. Yeah, cool there. We have our seeds, and I can create the account. So now let's create the account. You can just create account from not like SVM from Pinocchio. Yes, create account. And you see the API for creating account is pretty. From who's making the payment, the signer is an account info already. The land port is uh but the land ports are in the there. It's not this one. It's the one that we created initially. The states of the global states. So it should be where is the land port at? Taking account. Land port. Where do we calculate land port? Where do we calculate land port? Yes. Yes. Instead of global state data len, it should be global state, not this global state, should be global state len. That's why we add the len there. Global state len. Exactly. So to give us the length of the data we need. You understand now? So global state length of data that's 100. So if we did this also, so saying if we did the one that was there because it would be zero because the account has not been created, there's nothing, we don't know the size of the account, the state of the account, right? But now we need it to have the size of this 100, right? Because it needs to have a initialized bump, it needs to have a size that can contain all of this. Yeah, cool. So that's it. If we not do that, our program would have failed somewhere. Nice catch. So the lamp port now is minimum balance. Then the owner of this account is our create ID. What else? The space is also similar. Global len, global state rather, global state len. But now this is as U64 because space needs U64, but we created a U size U64. Oh, then the account we are creating is the global state account, right? Yep, and all is good. Then we just invoke signed on top of that. Because the PDA, we are creating a PDA, then we put the signer as the seeds for the PDA as the signer. You understand all of that already, basically. So the signer is we have seeds here. So to convert these seeds into a signer, and how do we do that? Signer from yep. Let's signer equals signer. Signer is imported from Pinocchio. Signer from from seeds now. Yeah, yeah, I think. Yeah, am I on the right track? Yes. Borrow that one. Yeah. And there's a convenience function to do this, right? There's a signer macro, but it's just there's a seeds macro. That way, I'll just pass instead of constructing seed from, I'll just do seeds. This macro, just do the seed and pass all the seeds here. So if I want to do a B global state, I could do that, right? I could do this, but I don't want to use the macro. Just want to use the struct itself. So that let's find ways to do it. Yep. So we invoke sign, then we do that. Sign us, bro. Sign us, and it should be an array because there might be multiple signers for this. Might be a multi-sig. So yeah, and we have successfully created our account. After we created the account, now we need to write to the account. So what are we updating in the account? So that is what I'm updating in the account section. Asserting the admin, the platform fee account, the supported token, and initialize. So let me do just copy this. Yeah, copy this and put it inside this place, but we're not using it, so right? Yes. So we want to borrow the account, we want to borrow the data mutably. So now we use bytemark. Yeah, yeah. Let's mm, global global state as state. Let's just call it as state. Global state as because we need the global state as state data. Yeah, state data. So now we use bytemark. We want to borrow it mutably, right? So bytemark from bytes mutable. Yeah, and we specify what type of data we are borrowing. So that is a global state data, right? We want to structure it as a global state data. So when we're getting something back, it should be a global state data. Then we just put in data. Let's borrow the data first. My bad. Just went to that. No. Let data state data is global state dot borrow data borrow data mutably borrow meet data try borrow meet data. I think yes. Try now. I can try borrow meet data. Yep, that one. Question wrap. So now we pass in state data here and them. So what's the problem? Sorry. Yeah, I should do this. And state data should be a borrow. I need to borrow. No, not good yet. That's the problem. Oh, I need to borrow it mutably. Uh, and let's borrow this mutably. And that is still not the problem. What the problem? Expected reference mute but found mute. Hmm. So I need to remove this borrow since I borrowed it already. Yeah, so that was the problem. So now what the yes, now I need to put all of this since I've borrowed this data mutably. Now I can now set the data since it's as global state. I can now set it mutably. So I do global state as state data dot now we have the admin. So the admin is what the admin is the pub key, right? So who is the admin here? The admin is the signer. So this signer we need to cover the signer to byte. Say how do we do that? We could just convert the key, just get the key, it's actually the key. My brain is melting. Signer dot key. Dot key is already the do work almost found expected, so I need to dereference that. I think yes, I need to dereference that. Yes, we've successfully added the signer. So next one, global state as data. After the admin, we save the bump, and the bump is what bump do we have initially? E bump. My bump here is this might not work because it needs it. Oh, wait, bump. Did I say what bump? Did I send bump? Okay. Initial bump is now this. That I worked out of the box. So next one is global state as state data. After we save the bump for the save again, the initialize is true. We do one, right? One. We do a U8, one as U8. So one means true, zero means false, right? So I was telling you that we initialize this guy. Then what else? So global state, as state data, after initialize, platform fee account is platform fee account is the token account. Token token account dot key. Yeah, and I need to do reference that because they borrow already. What else? Global state as state data. I need to be off this call by 3. I have another call. I have a call in the next 9 minutes, guys. So we'll test this tomorrow and move on to the no tomorrow, not tomorrow. Wednesday. Yes, tomorrow. Let's do tomorrow then. I need to be off by that. So I will make this a repo that people can contribute to. So then, so you guys can just get into it in your spare time and see if you can push it further before tomorrow. Basis points. We need to get the basis points. Okay, I would deal with that tomorrow. But we need to have the basis points. So the basis points will be coming from data. So, but we need to know the length of the basis point, right? If the basis point is a U64, so we need to get the U64 of that data. U64 is 8 times 8, so that's a U8 of 8. That's what I could just, okay, let me do it this way, like I did it here. So, I can use byte mop again, which is good. Let me call it initialize, initialize, initialize switch. So I need to specify the basis point. Fee. Fee in basis point is U64, U16, U18. Let me use U16, U16. Then that's the reason I need. I need to know the length of this data, so I can just do an implementation of length on that. So I can know how to track. This is just a U8 of 8. I can just put 16, but yeah, everybody knows that. So initialize, switched, copy this, paste this, to byte mark of self, dot vec, zeroable pod. I don't have that yet. Zeroable, plain old data. I think we're good to go here. So I can now get the length of that one. But before then, after platform fee account, let me remove this. I don't need this. So I already know what I'm doing. So now global state as state data. We have the admin, we have the bump, we have the initialize, we have the platform fee account, we have the platform fee supported token mint is token mint dot key. The reference it. And that is all. We'll get into testing tomorrow. Thank you all for now. We've done everything. But we cannot know if okay, let me just do the final touch on getting the instruction data. So you know if we are passing the account from the client, we want to know the instruction data that are passing. Like so, let's say I want to initialize with 20 BPS now. So that's like I think 0.2% fees, right? So I can get that also here. Let me do let IX data because I'm passing extra data is I can now use byte mock, then use that one I wanted to do before. Byte mock, try from pod unaligned. Then the bytes would be is it okay. Data. The instruction data will be whatever you're passing in data here, right? So and I need to specify what type of data I'm cutting from it. I'm cutting this initialized switched data from it. That means I want to get a length of this initialized switched from this data. So how do I do that? I already have the instruction data here. So if something goes wrong, I want to map the error into an invalid structured data. Yup. Yeah, just mapping the error. So now I can now get this one will now be data from zero to initialize switched learn. It's not learn on it. Expected U8 expected U8 but found okay U16. It's also U16. So I need to specify the length of it. Then also that's two. Yes. No, no, sorry, my bad. I think this should work. This should work. Expected U8 found U8. Okay, I'm in it. Let me just see how I did it here. I'm rushing out now. Hmm. Okay, okay, let me just do it this way instead of instruction data. Okay, I already called it instruction data. I was shooting myself in the foot. Instruction data already. Dot cbps. That's 20 bytes. That's that's what I should have done. So this is me doing it in a smoother way instead of cutting it off the data and also I'm already cutting it off the data here with byte mock. I'm using byte mock to get this data from data, right? So yeah, yes, that's a link. So that fixed. I just fixed the error of that. So if I know how to do it that way, if I know how to cut it from instruction data there, I'd have done on array since this is U82, I'd have done data then slides from zero to blah blah blah. Zero to two. Zero to two, basically. This this should have done that for the expected U82 found U82 dot okay, let me borrow if it will work. It's not working. There's a simple way to fix this. But yeah, so that's basically it. We'll pick it up tomorrow and see how we go. I have the WG call right about now. Yeah, yeah. Let me save this push to GitHub and see. It. Let's let me just share that one. Yeah. Alright, guys. Thank you for the time. Now time to join the stream, and this is the anchor founder. Not yet. I always forget to do that. Presentation. Minutes. Yes, and this is the anchor founder. See you guys tomorrow. I'll communicate the time for tomorrow.